Okay, so today we're going to be talking about area and perimeter of parallelograms, triangles, and trapezoids. Have you done, let me just figure out where you guys are coming from, have you learned how to find area of a parallelogram? Did you do that in 6th grade? How about area of triangles? Surely you did triangles. Triangles? You never found area of triangles? Like 5th grade maybe?
We did in 6th grade and 5th grade.
Okay, I thought you should have. And then trapezoids is probably new. You probably haven't done trapezoids yet. We're going to attempt to cover this all in one lesson just because there's so much in the realm of geometry that we have to cover. And you're just applying formulas. And there's a lot of similarities between the three. So hopefully we'll be okay with this. So our first objective, we're just going to talk about what perimeter and area are to make sure you're good with that. And then each objective deals with finding perimeter and area of a different shape. Okay, so perimeter is just the distance around a shape, and it's measured in linear units. So it's something we could measure with a string or a ruler. So you might find the perimeter around a field, say. You're just finding, like, if you wanted to put fence around a field, you're finding out how much fence would you need to fit around the entire field. We could find the perimeter of this classroom by measuring all along the outside walls. Area is two-dimensional. It's the two-dimensional space occupied by an object, and it's measured in square units. So this example, we're just starting with a rectangle because you've done rectangles before. We can find the perimeter by just adding up all the distances around the shape. So across the top, we have 8 inches, and then we have 5 inches. What is it going to be along the bottom? Just say it out. 8 inches, and along this side, 5 inches. So to find the perimeter, I need to add 8 plus 5 plus 8 plus 5. I'm just adding all the distances around the shape, and I end up with 26 inches. Now when I find the area, question?
Yeah, my glasses are in my locker. Can I go get them?
Yes, go ahead. Okay, when we're finding area, we're interested in two-dimensional space. So these little squares that I've drawn on this rectangle, if we were to fill up this rectangle with these squares, each square is representing a square inch. So it's 1 inch all the way around. If I were to fill the whole thing up with those squares, how many squares would I have? Sophia? I would have 40. And what did you do to figure that out? What's that? 8 times 5. So we don't need to draw in all the squares and count them all up. We can use the idea of an array, and we can do 8 times 5. So when we're finding area of a rectangle, we're just multiplying the length times the width. And we get 40 square inches. We put that little 2 up above the inches to tell us that it's square inches, not linear inches, but we're filling it up with squares. Athena?
There are 9 squares across.
Are there really? 1, 2, 3, 4, 5, 6, 7, 8, 9. You're right, there are 9 squares across, so we need to change this problem, don't we? Or we could just, you know what?
Yeah, can you just leave it?
Let's just get rid of a square. Let's pretend that
never existed.
this did not exist, okay? We're just going to take off this part of the rectangle.
Same.
Okay, are we happy now? Not good? Okay. Thank you for noticing that. You know, I counted them and I was careful to make sure that this rectangle was the same size because these are all cute little movable rectangles. See? I can take those out. But obviously I didn't count carefully enough. Okay, now we're going to move into finding perimeter and area of a parallelogram. Okay, first of all, what is a parallelogram? Anyone tell me? How do you define? You can kind of get it from here. A parallelogram has 2 sets of what? Parallel lines or parallel sides. 2 sets of parallel, whoops, that was crazy. 2 sets of parallel sides. So if we look at this parallelogram, these 2 sides are parallel, and these 2 sides are also parallel. And I'm using 2 marks on that set just to show that they're a different set. So the 2 on either end, 2 across from each other, are parallel. All rectangles are parallelograms because rectangles have two sets of parallel sides. So all rectangles are parallelograms. You get lots of practice writing parallelograms. But not all parallelograms are rectangles. Why is this parallelogram not a rectangle? What's wrong with it? What's wrong with it that doesn't make it a rectangle? Adam? Why isn't this a rectangle? It's leaning, and what does that do? Why is that not okay? Why can't I call it a rectangle? Changes the angles. What kind of angles does a rectangle have to have? Right angles. Good. Rectangle has to have right angles. So I wrote down here a parallelogram. I get to spell it one more time. Parallelogram is just like a squished rectangle. So it's like we took the rectangle and we just kind of sat on it and it wasn't very sturdy, so it just kind of slanted off to one side. It's like a squished rectangle. If I move this rectangle over, and I happen to make a rectangle that fits this parallelogram, it almost looks like the parallelogram. We can see this yellow triangle over here. If we put it over here, so if we cut the yellow triangle out of our parallelogram, it would make the other part of a rectangle here, wouldn't it? So if I took this yellow triangle, which I can't do, I can't cut this out and move it, I wish I could, and I put it right here, let me just draw it. If I cut this off, and I put it, whoops, that's not what I wanted to do. There we go. If I cut it off, and I put it here instead.
Still not a rectangle.
Okay,
No,
so if I
you
don't
took
cut
off
it
that
off, but if I leave it, and then I add the rectangle over here, I'm gonna have a rectangle.
They need to cut off that side of the blue part, because the blue part is the yellow you
So what we have here, when we're looking for the formula for the area of a parallelogram, it's basically the same as the formula for area of a rectangle. The area just equals the base times the height. We care about the height of the parallelogram, not the length of the side, because we want to be able to build a rectangle around this parallelogram like this. So this is where we would actually cut this part off. Then this would still be the same area as the parallelogram. If we cut off this part and we put it over here instead, it's still the parallelogram, right? It's still the same area, but now it's a rectangle, so we can use the length times width. So when we find height, height is always a measure of a perpendicular line segment that connects the bases. So it has to be perpendicular to the height. That's going to be true when we do triangles. That's going to be true when we do trapezoids. We always want to look for this right angle, which is another word for perpendicular. Perpendicular means right angle. So to find the perimeter of this, we're going to use the actual numbers that are given here. We're going to use fluorescent green. We're going to say 7 plus 8. What's the length of this side? 7. It's the same as the first, and this one would be 8. So we have 7 plus 8 plus 7 plus 8 equals 30 meters. And this one is just linear, so we're not going to square that. It's just 30 meters. Now to find the area, we're going to do the base times the height. So the base of this rectangle, would it be 7 or 8? Colin?
So.
It would be 7. Why did you pick 7 and not 8? Because what? Well, yeah, it's in a straight line, but there's more to it than that. Anybody know, Liz? Bottom and the top, okay, even more. Athena?
Because it's on the top, it's the same as the bottom, and the bottom is the base.
Okay, but what if we flipped it over? Then could we use the 8? Sophia?
Because, the line is around is perpendicular.
Good. But Sophia has hit on it. This line needs to be perpendicular to the bases. So since it's perpendicular to the side that's 7 meters, that's the side we have to use. So our base is 7 meters. The perpendicular line is 6 meters. So we have 42 square meters. So if we cut the piece off that parallelogram, we turned it into a rectangle and filled it up with our little 1 meter squares, we're gonna have 42 of them. Okay, next one is one for you to try. So let's see how we're doing for time. We're running out of time. So we're actually gonna do this one together. We're not gonna get through this whole presentation today. So let's first look at the perimeter of this. I'm gonna call on someone to give this to me. I'm just gonna pick you because I can't find your card. Let's see. Bailey,
Yes.
tell me what numbers I would use to find the perimeter.
15 bucks.
Good. So 15 plus 12. Good. Plus 15 plus 12. And when we add all that together, who can tell me what we get? Sophia? 54. We get 54 inches. Okay, then to find the area, which numbers are we going to use? Liz? 15 and 10. And how did you know to use 15 as your base? Good, good. It's perpendicular to the height. So 15 times 10 is what, Liz? 150. And what units did we write? Inches squared. Good. Okay, we have a couple minutes. We're going to keep going as far as we can. So let's talk a little bit about finding perimeter and area of a triangle. Okay, when we're talking about triangles, a triangle is like half of a rectangle. By doing some manipulation of the triangle, we can turn it into half of a rectangle. So I'm just going to put it here in the middle of this rectangle so you can see that. If I were to cut out these two yellow parts, I could combine them to make an area equal to the blue part. So triangles always can be manipulated in some way to form. If you had two of the same triangle, you can always put them together in some way, even if you have to cut things off, to make a rectangle. So when we do the formula for area of a triangle, we do 1/2 base times height. We take that formula for a rectangle and we just cut it in half. So it looks like this. Area equals 1/2. Whoops, I meant to draw my fraction bar that just disappears all the time. Area equals 1/2 base times height. And again, you have to look for that perpendicular segment to be your height, and then the base is always the side that is perpendicular to the height. Okay, so how would I find the perimeter of this triangle? Let's see, Zoe. Perimeter, we just want the distance around. Yeah.
9 plus 9 plus 10.
Good, 9 plus 9 plus 10, we only have 3 sides, so we have 3 numbers, and what does that equal? 28 centimeters. Linear, so we don't put any little 2 there. How about the area for this? Let's see. Katie, can you tell me how to do the area? 10 times 7.5, but what else? Divided by 2. We need 1/2 of 10, which is the base, times 7.5, which is the height. And then you can multiply times 1/2, or you can divide by 2. It's the same thing. Liz?
Would doing 5 times 7.5 work?
Yeah, you could. So she's asking, could you half 10 right away and just do 5 times 7.5? And you could. That would definitely work. You get 37.5 square centimeters. Okay, so we're going to stop here with this for today.